Alright, I'm just going to do the next one here, number 12, because I realized I didn't cover exponents and division. So this will be a good one for that, even though these numbers here are going to require a lot of reducing. So let's start with talking about dividing fractions, okay? So if you were to take a pizza and divide it by 3, right? Full pizza, divide by 3, you get what? A third of a pizza. 1 divided by 3, or I'll write it this way. 1 divided by 3 is the same thing as 1 multiplied by 1/3. Do you see the relationship there? It might help if I wrote this 3 as 3/1. So in the case of dividing fractions, it's actually the exact same thing as multiplying by its inverse, by basically the upside down fraction. So we can take this problem as it is right now and rewrite it. Actually, I'm just going to erase this half and rewrite that. And then this is now a multiplication problem. So that probably made things a lot easier right there. You might be able to see a few things to cancel out already, but we'll wait. So we're going to start with talking about how to reduce when you have exponents right there. Okay? So I'm going to rewrite this as a single fraction again. That times that over that times that, because when you're multiplying fractions, you just multiply straight across. So this is the same thing. I haven't done any math yet. So it's helpful when thinking about exponents to think about their expanded versions. For example, y to the 5th, what is that? That's y times y times y times y times y, right? There's 5 y's, all still multiplied with each other, same as everything else. Everything's being multiplied together in this case, right? So when you think about it like that, and you think about this as y times y times y times y to the 4th, there's 4 y's. Alright, now you can see that they actually can cancel each other out even though they were different. But in this case, there were 5 y's in the denominator, 4 y's in the numerator. So you can only cancel out 2, 3, 4, 1, 2, 3, 4. You still have a y, but no longer a y to the 5th. So that is simplified. Not to mention, you definitely simplified your numerator by completely getting rid of the y's. Alright, so I'm going to rewrite these as y to the 4th, which got canceled out. I'm going to rewrite this as y to the 5th, And kind of the easy way that I would change this notation is to cancel out the y to the fifth, making it y to the first, or just y, right? Because 4 y's canceled out 4 out of the 5 y's, but there's still 1 y left. All right, we can do the same thing with the z's and the v's. Okay, so more z's up here than down here. But there's still 5 of them here, 12 of them here. So all of these are going to cancel out, and 5 of these are going to go away, leaving us with 12 minus 5, or z to the fifth. Okay, the opposite thing happens with the v's, more v's on bottom. All right, but 5 of them are going to cancel out, leaving you v to the second, or v squared. All right, so let's rewrite. Let's see, on the top we still have 80 times 14 times z to the fifth. On the bottom we still have 49 times v squared times 25. All right, that's as much, 25 times y. That's as much as we can reduce these variables right there. But there's still a lot of reducing we can do with just these numbers right here. For example, 80, let's see, 5 times 16. All right, 14. I'm going to write as 7 times 2, because this also has a factor of 7 and this also has a factor of 5. So we still have our z to the fifth, right? So 49 I'm going to write as 7 times 7 times v squared times 25 I'm going to write as 5 times 5 times y. All right, so that helps a lot. We can get rid of a 5. We can get rid of a 7. All right. And I don't think there are any more common factors that we can reduce. So this 16, I'm just rewriting down here, 16 times 2, I'm just going to multiply that out. 16 times 2 is going to be 32, z to the fifth, and the bottom right here, 7, and remember how you can change the order? I'm going to move the 7 next to the 5 and do those first, right? So 7 times 5, 35, v squared y. That is your final answer right there.